The next property of phi function is this. Suppose n is a positive integer greater than 1. Then the sum of all positive integers k which are less than n and relatively prime to n equals 1/2 of n times phi of n. The proof of this fact starts by considering all the positive integers less than n and relatively prime to n. How many of them will be there? Phi of n, because by definition of the phi function. So let them be these ai's, a1, a2 and so on up to a of phi n. Now next you note this. For any integer a and n are relatively prime, that is their GCD is 1 if and only if n minus a and m are relatively prime. There is no need to elaborate on this because you already know this fact. It comes from properties of GCDs. So these integers, these n minus ai's will be relatively prime to n because these are relatively prime to n and we can apply this. But additionally, these n minus ai's are also positive integers less than n. Why? Each n minus ai is positive because each ai is less than n. That is why. And each n minus ai is less than n because each ai is positive. So you are subtracting something positive from n, so this will be reduced. But then what can you say about these n minus ai's? They are nothing but these numbers, the original ai's in some order. And that's why if you take the sum of all the ai's, then that equals the sum of all the n minus ai's. So then you gather all the n's, how many of them are there? Phi of n. So that's how you get n times phi of n minus all these ai's. We have taken minus outside because then we recover this sum. Finally you add this sum to both sides, then it vanishes on the right hand side and on the left hand side you get twice the sum. And then you just have to write one more step, you divide both sides by 2. So that's how you get 1/2 of n times phi of n on the right hand side, and on the left hand side you have this sum which is that sum, the sum of all positive integers less than n and relatively prime to n.